So far, from a cumulative frequency curve, you can find a 5-point summary. All right? What are the 5 points that you can find? Is it? Yeah, so min, Q1, median, Q3, maximum, right? But there are, as we said, that line, it's not a line, is it, baby? What is it? I'm looking for the exact words. We should just, every time I say 5 words. That line is not a line, it's an infinite number of points. Okay? So therefore, we can use that line to find values. You all right, Melanie? Yes. We can use this line to find values for particular points. So when I said in the title, finding other percentiles, all right, what do you think I mean by percentiles? Well, let me tell you, the median is the 50th percentile.
Like where each of the percentiles of each point of the line.
So the upper quartile value would be the 75th percentile. The lower quartile would be the, right? You guys would put yourself in which percentile of the school, mathematically?
75th.
So you put yourself in the 75th percentile.
Like grade-wise or intelligence-wise?
Either way should match. See, I would put you in the, like, 10th, 5th percentile or something, 10th percentile. Why? The 10th percentile means...
Oh, we're like...
Well, actually, it doesn't. I was being mean there. How do you... So, you guys need to be worldwide, let's say you are in the 98th percentile. That means you're in the top 2% of people in the world. All right? It's amazing how you guys don't really appreciate that about yourselves. If you take everyone in the world, you guys would be, because there's so many people out there, and it's not necessarily bigging you up too much, because billions of people don't even get any education. You know, doesn't really, it's not something to be necessarily proud of that you're better than them at maths. All right? But in terms of the education that you have and so on, that is what we're talking about. So with the percentiles, we can look at different options, not just the top 25%, the bottom 25%, the middle 50%, and so on, yeah? So, for instance, we need to look at questions like what was the minimum weight of the top 10% of fish? Okay? So what is the minimum weight of the top 10%? Do you want to write that down, just in case you didn't realise that you're writing that down?
Yes.
So to find this, we have to look at which axis first, the weight axis or the frequency axis? Frequency, because 100% is 80 of them, okay? So what would the top 10%? So I need to break off only the top 10%. So where would the top 10% be? Well, what is 10% of 80? So 10% of 80 equals 8. So what I can then do is take my graph, and I should always show my lines on my graph. So I can go from 80 and each square is worth 2. So I can go to 72, isn't it? Read across. That would mean that this area here represents the top 10%. And the value is at 72, isn't it? Missing your straight edge again. What do we do then? We read down. That's why we need our rulers, our straight edges, and we read the value. So what value would it be? 84.
83.
84 would be up here.
Oh, nope, 82.
82.
It doesn't go up by 2.
No, it doesn't go up by 2, this scale, does it? So we know that the minimum, or we could even say the top 10% are 82 kilograms and up. Okay? So the next question that I said we needed to figure out was how many weighed more than, let's say, 86 kilogram. How many weighed more than 86 kilograms? So what do we do this time? So we have to, again, read off our graph, but go backwards. So we go from 86, right, 86 kilograms up there. And I read across. And I've got an answer of. So that is 78. And this is where the common mistake happens. People would say that it's 78, but the answer is actually 2, as he was saying, as Neil was saying. So 2 weigh more than 86. All right. How many weigh less than 86? 78. Okay. So it depends how you want to, how you need to read your cumulative frequency. Okay. You need to go above or below. The value itself can't always be the value that you read. Yes. What's the question? Well, if I read across here to 78, look. You happy that you got 78? 86 kilograms. Comes up at 78, but the question was how many weighed more. So more is from 86 up, yeah? So therefore, when I get here, I need to go 78 up. So from 78, and we've only got how many in total? So 78 up to 80 is only how many? 2. So that's how we answer. So if I said to you then, how many weighed more than 68 kilograms? How many weighed more than 68? Let's have a look. More than 68. So what we're looking for is we go to 68. So 66, 67, 68. Okay, we read up. And we read across. So I've got a value there of 22. So more than 22, so we do 80 in total minus the 22 gives me 58. So 58 are more than 68 kilograms. Compasses for this work, Annie? Do we need that or do we need to stay focused? Okay, can I just make one point very clear to you? what do you notice is all over my graph? Lines. I've done them different colours just so you can see what I'm working. That doesn't matter. But I was saying this to Bella yesterday. If I want to see working with cumulative frequency, if I want to confirm that your answer that you've written down in an answer space is correct, I will not draw on your graph. I will look for the lines on your graph. And if your number is exactly what I'm expecting it to be, fine, I won't need to bother. But if your number is slightly away from mine, what I will then do is I will look to your graph for evidence that you have done the correct process and you maybe just lacked a bit of accuracy or your curve was a bit different. I'm not going to draw the lines on there for you, all right, because I can't guarantee that you did what I'm going to do. So although I might confirm your number, I can't guarantee you did the same thing and got that number. You might have just guessed and got lucky. Therefore, you must, all the time with a cumulative frequency curve, when you're working these things out, show evidence by putting the lines on the graph. And it doesn't matter how many times I tell you this, at least one of you will not bother in a test. All right? Always happens. So show the lines. Right? Just one other thing as well. Straight lines. Being careful. So you would not believe how often I see this on a graph. Okay? So let's say I'm working out the 50th percentile. So how would I do that, Izzy? The 50th percentile is, yep, so I'm going to go across to 40, and I'm going to draw my line. Oh, it's going slow now. Yeah, and I draw a line down. I see it all the time. Not quite to that extent, but your answer is wrong because you can't draw a vertical line or even a horizontal one. You just slap your ruler down, draw a line, draw, you know. The other thing that we'll see is, you know, we start at 50, go across, okay, read down. So I've done a couple of things. I've got my lines aren't horizontal and vertical, and I've not actually gone directly from the curve. I've kind of decided where I want it to be and just gone for that. All right, those would be, I wouldn't worry about marking those, just mark them wrong. It's inappropriate, incorrect methodology there. Yes?
Can you do like a dashed line?
Dashed lines are fine, yeah, I don't mind. All right, dashed lines are fine as long as they are horizontal and vertical. Okay? Also, don't do what a number of you just did with this one and read scale wrong. That's a, you know, that's a bit of a no-no as well. So that's it really. We have now covered the 5-point summary using cumulative frequency. We've got different percentiles. So if I said to you, what would the top 30% be? All right, you just need to find 30% of whatever the maximum cumulative frequency is. Go to that point, yeah? So that's about it. Hopefully you are okay now with converting from your 5-point summary into a box and whisker plot. Yeah? Any questions about that? No? Cool. Well, we have